So this is the pre-lab for the inference for a single sample. That's lab 7. Like always, I've sent you the .rmd in a Canvas announcement, and you'll need to download that onto your computer and upload it to RStudio Cloud in order to be able to work with it. So when you open it up, it should look like this. And of course, the first thing we need to do is add in the packages that we use, library mosaic and library GG formula, then run that chunk. All right, so far in the labs, we've done inference using simulation methods. Lab 4 was about using the bootstrap to do confidence intervals, and lab 5 was about using randomization to do hypothesis tests. And now we're going to do inference using a distributional approximation. So in this lab, we're going to cover two particular parameters, the ones from chapter 6, a single proportion and a single mean, and that's why this lab is called inference for a single sample, because it's just about one particular parameter. So when we use a distributional approximation, we're going to use a theoretical distribution that we know something about. That means for a single proportion, we're going to approximate using the normal distribution, and for a single mean, we're going to approximate with a t-distribution. And either way, the thing that we're going to need is a formula to approximate the standard error. So I'm using LaTeX again with the dollar signs, and then just typesetting out in math what these equations are. So for one proportion in a confidence interval, we would do the square root of p hat 1 minus p hat over n. And in a hypothesis test, we approximate using p naught, the null value. So it would be square root p naught 1 minus p naught over n. And if we're doing inference for just one mean, then we get to use the same standard error calculation in both the confidence interval and the hypothesis test, and that's s over the square root of n.